Hello, my name is Rob Sandstrom. Today we're going to discuss how we can use snap-together joinery to create furniture pieces, shelves, storage racks, etc. Here's an example. This is what we're going to create today. This is a storage shelf used for light-duty materials, and what we've done is taken a piece of 1/4-inch plywood and put in joinery that allows us to take each piece, cut it, snap it together, and this is held together nice and tight without any glue. Obviously, if we want to make it permanent, we would put some glue in these joints. But you can see how strong it is already just by making sure our joints are nice and tight. So what we'll do in the video today is go through the design software, Vectric VCarve Pro, show how we put the slots, how we decide where they go, and how we create the joinery necessary to cut this piece. We'll be using Vectric VCarve Pro to do the design and walk through the design thoughts and concepts as we build a shelf similar to this one. It won't be this exact shelf. There's been some improvements put into the design, such as the support of these shelves. You'll notice this is sagging slightly. So we're going to take these backs that attach the shelves to the walls, and we're going to move them up adjacent to the shelves so they act as a support mechanism as an example. This is an example of a shelf we're going to build. As you can see, the support bracket, which attaches the shelves to the wall, also is directly underneath the shelf, helping to support and reduce sag when we're loading. Each of these support brackets are going to be 2 inches by 18.5 inches long. Each shelf will be 18.5 inches long and 4.25 inches deep. The side structures will be 4.25 inches deep and 21 inches long. Those numbers will become important as we walk through the design of the shelf in the Vectric presentation. We'll be using snap-together joinery or slot and tab joinery. Each of the shelves and each of the support brackets are held into the sides through snap-together joinery. Notice the nice tight fit and how the shelf tabs are nice and flush with the sides of the plywood holding them. This is accomplished through using a storyboard. Development of the storyboard will not be covered in this video. By using this storyboard, we could tell the proper size of the slot width, in this case 0.234, and the proper size of the tab to fit into that slot, which is 0.75. So throughout this design build video, we will be using that size for slots and tabs. So now that we know the design of the shelf, we know the right size of the slots and tabs, we can move into the actual design video. So we'll start this project by creating a new file, and we're going to make it single-sided. We're going to make it the size of the bed, and then we'll resize from there for our first sheet. And so it's going to be 24 inches wide, 36 inches long in the Y direction. We'll make the thickness 0.235, which is what I measured for the plywood I'm using. We'll put the Z0 off the bed, and initially we're going to put the XY datum position during the design phase in the center. That allows me to use symmetry when designing the materials. Hit OK. First component we want to design for this project is the support bracket, or the piece that goes across the back of the shelf and attaches to the wall. That component is 2 inches by 18.5 inches, including the tabs. So we'll start by making the tab piece. Select a rectangle. We'll come in here and we want this to be 18.5 inches wide by 0.75 inches. Apply. Close. Next rectangle for the piece we want 18 inches by 2 inches. Hit apply. Hit close. Take both of these and we'll center them in the material widthwise, so they should be centered within themselves. Close. Take this piece here, the tab, and put it right in the center. So I select the inner vector first, then I select the outer vector, and instead of aligning the material, I'm now going to align it to the vectors, and I want to align it in this direction. And just should be already aligned here, but I'm going to make it sure. All right, so close. So now we're at a point where I know, let me move this up a little bit. All right, so now I know this is centered. I can make the component by taking out the parts of the vector that are no longer needed. So we'll use the interactive vector trim tool, make sure the rejoin trim sections is checked. Click here, 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 and here. Close, and the result should be a closed vector. We'll validate, close. Okay, the next thing I want to do is create holes to mount this bracket to the wall. I want to make them 16 inches apart, and the best way to do that is to first create one in the center and then mirror it. So now we're going to create a circle right there in the center. We're going to make that 9/32 equal. That's the size I want. Hit apply, hit close. So now we'll select the circle, and we're going to use the move tool. Using these tools keeps the accuracy. We're going to make it 16 inches total, so I wanted to make it minus 8 inches, 0.0 inches in the X direction. That puts it exactly centered 8 inches over. Hit close. Then I use the flip tool, and since everything's centered, I can flip it horizontal and create a mirrored copy, and it should be exactly in the center. And we're set, and we've got our first component done, which is the bracket that goes across the back. It supports the shelves and allows it to attach to the wall. We'll move on to the second component at this time, which are the shelves themselves. That component is 4.25 inches by 18.5 inches with 0.75 inch tabs. We'll start out once again by making the tabs. Use the rectangle tool, and we'll make it 0.75 by 18.5. So 18.5 inches wide, 0.75 inches tall. Hit apply, hit close, hit a rectangle. We'll start in this corner, same corner, so we're aligned. And then I'm going to make this one 18 inches and 4.25 inches. We're doing that because this piece will be like this one with tabs. So hit close. And the first thing I want to do is align these along the bottom. So this is the first vector. I'll click the second vector. We'll use the alignment tool again. See how I keep using this tool. We're going to go ahead and align. Oops, wrong direction. We're going to align in this direction so it's aligned along the bottom. Then we're going to align so that they're centered. Then we're going to align by selecting this one first and this vector second, that they're centered. All right, so now we're centered. Next step is to put these in the right area. So the front of the shelf, I want to make 0.5 inches away from the bottom. So I'm going to select this. I'm going to select this vector. I want the tab 0.5 inches in, and I'm going to move that tab in the Y direction 0.5 inches. Apply. Close. And on this tab that I'm making, I'm going to want to make this 0.75 inches from the back. So this is the front, this is the back. I select that vector, I hit Control, and then I can move that vector straight up. I will take this vector and this vector now to make sure they're perfectly aligned. Alignment is everything when we're building these kinds of components. And I'm going to make sure they're aligned. Remember, I select this vector first, this vector. That will allow this one to move to the inside edge. And now we're right on this vector. So I want to move this vector now. Close. I want to move it using the move tool, negative 0.75 inches in. Close. And the reason I wanted to do that is the shelf is actually about 0.2, I'm using nominal values, about 0.25 inches thick. It's really probably 0.23 or so. And I'm going to put the tabs or the slots for the shelves themselves, so the shelf supports, these ones right here, I'm going to put those in starting about a 1/4 inch in, allow a 1/4 inch this way, and so the tabs I want to be able to be far enough in where they're not blocking us putting in these supports. Now I will turn it into a component by using the scissor or interactive vector trim tool. Remember, this has to be checked. And now we have our second component built, which is the shelf. The next component we're going to build are the side pieces, which actually hold all the shelves and the support brackets, and it admittedly is a more complicated piece. But taking one step at a time, it's not all that bad. It's just that we got to make sure everything is done right for everything to align. Well, actually the sides are 20.5 inches by, use the rectangle tool, 20.5 inches by 4.25 inches. So we're going to take it 20.5 inches by 4.25 inches wide, hit apply, hit close. Alright, so we have our basic structure now. Again, check the alignment. We want it aligned in the horizontal direction to the material. Looks like it is, so that when we build our pieces, everything is done in a way that is symmetrical. So the first thing we want to do is I'm going to take this shelf, which is going to be used to support the material, and I'm going to make a copy of it. So I'm going to click on it again twice, then I'm going to hit the control key, grab the shelf, and I'm going to bring it up into this piece above, and I'm using this simply as a guide. So the first thing I'm going to do is now click on the outside material, and I'm going to use the alignment align to selection. Okay, so now we're aligned this way. Next thing I'm going to do is I'm going to take this piece here and I'm going to align it to the inside edge. So now I know that this piece here is actually aligned to the inside edge. So I now know that this is exactly aligned with this, and I'm going to move this in because I want the slots for the top shelf to be approximately 0.25 inches down. So I'm going to allow me to have material at the top. So I'm going to take this inner component, I'm going to use the move tool again, and I'm going to move it in the X direction, 0.25 inches. Okay, now that I've done that, I know where my slots need to be. And so I'm going to go ahead and click off that, and next thing I'm going to do, I'm going to use my rectangle tool to make my slots. Pull that up. So you can see it's 0.25 by 0.75, which is what I expected. Hit apply. And I'm going to make another rectangle, similar in the other slot location. 0.25 by 0.75, apply. Hit close. And now I've got this in the location. So this material, this shelf is going to slot right into these slots when it's all said and done. We'll come back and adjust the size of these slots and make them so that all of this will fit together in the future. So now I want to make the slots for the bottom part of the shelf, and I'm going to go ahead and I'm going to take this material and I'm going to move it. So I'm going to hit this material first, I'm going to select this component, and once again I'm going to use the alignment tool to align to the right edge. Hit close. And what I know is I want 2 inches of support. That's what this width of this is. And I'm going to slot this in the back, and I want it to hold up the shelf as support. So since this is 2 inches, I'm going to want this shelf up 2 inches when I'm creating the support. So to do that now, I'm going to select the inner component, use the move tool, and I'm going to move that minus 2 inches. And apply. Close. So now I'll go ahead and make my slots in this area similar to the ones I did up top. Okay, to make the slots, I'll do the similar process. I hit a rectangle tool. Let me blow this up to make it easier to see. 0.25 by 0.75. Apply. Apply. Close. And now I have slots at the top and the bottom where these shells are actually going to be located. Let me move this component out of the way so you can see where those slots are. Okay, those slots now are all located at the top and the bottom where I want the support. We want to make sure these slots are all the right size. From a previous effort, I created a storyboard in which I determined the right slot size for these would be 0.234 inches thick and 0.75 inches long to meet these tabs. So we're going to make each of these slots 0.234 inches thick, and we're going to keep the 0.75 inches. So with that, let's go ahead and do that at this time. So we'll select all of those. We'll hit the resize tool. We're going to scale items individually. We're going to make sure that the link XY is not clicked. It is not. We're going to create 0.234 inches. Hit apply. To make these material fit together, we need dog bone fillets put in each of the corners and in each of the areas where they're going to meet up. Let's go do that at this time. We do a dog bone fillet by selecting the fillet tool, and we use dog bone fillets. And I know that this is the right value right now, but just to be sure, you have to know what size bit you're going to use. We're going to use an 1/8 inch bit, so I put 0.125 inches in there times 0.5. And I hit the equal, and Vectric does the math for us in figuring out the radius of the tool. We select dog bone fillet, and now we'll put the fillets in each of these. Hit close. We'll move this further off to the side. I shouldn't need it again, but if I do, I want to make sure that I have it available. So the next thing I'm going to do, just to make sure everything's aligned, I want to go ahead and, for a second, group this component. Once again, this continuing to align across the center is important because I've just run into problems too many times. You don't have to do it, but that's what I do. And I'm going to hit alignment, and I'm going to group it across the center to the material, and that tells me everything is on job center. I'll select this again and I'll ungroup it. Now that we have our top and bottom shelf, we need to put the individual shelves in between. And I'd like to have them equal distant as I go through. So the best way I find to do that is, again, by using these alignment tools, which are a powerful source. The first thing I want to do is equidistance between the top shelf and the bottom shelf. I'm going to go ahead and create a vector that will allow me to make that alignment. So I'm going to hit the rectangle tool. And I'm going to pretty much go right along the line there so that I'm centered in that direction, and right along the bottom here, and that will allow me to center between those. Maybe what I want to do is change that slightly. I want to center between the actual shelf surfaces, so I'll go to that selection and I'm going to hit close because I want to actually resize that to make sure it's along the bottom. So I'm going to resize this so it's on the bottom part. There we are. And come back over here just to make sure it's along the bottom close enough. Click off there. And so now I have a vector to place these shells in. So I'll use the alignment tool by first I will make copies of each of these slots since they're the right size. I select them, I click on it a second time. Now I'll hit the control key and I'll move this one down, making sure I line them up in the, keep the control key down, that one, and I want 3 shells. So I'm moving along that line, that dotted line, to make sure everything's aligned. So now I have the 3 shelf brackets that I want, and I want to put those equidistant across. So the best way is to use the equidistance tool, and I'll do that by first clicking on the alignment tool, and I'm actually going to use this tool down here. These 3 holding the shift key down, these 3 holding the shift key down, and this is the last vector. And I'm going to now select this tool. You'll notice when I selected all of the vectors together, it thinks of these as individual closed vectors. Doesn't matter that they're separated out from each other. So when I hit the equidistance, it's going to go in the order of the vectors. And so you'll notice it's equidistance from here to here, 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 to here. That's not what I want. Let's hit Control Z and undo that. And what I really want to do to get the right spacing the way I want it is I'm going to go ahead and select these vectors. Then I'm going to hit the Shift key and select that vector last. I'm going to use the equidistance, and now I notice that I have equidistance between this box and this box for each of the shells. Then I'm going to go ahead and I'm going to select all of these by putting a bracket around them, use the Shift key, and I'm going to now do that again, and now you'll see they all align up equidistance across from each other. So I have the right spacing I wanted for the shells. Hit close. We want these to align 1/4 of an inch in. So what I'm actually going to do is I'm going to take this component and I'm going to move it down 0.25 inches by using the move tool in the Y direction minus 0.25. Hit apply. So now I know I have 0.25 inches between this line and the back of the shelf, which gives me plenty of plywood for support of my shelf supports that we're going to be putting in here without taking a chance on busting out the plywood in the back, and a place to align those shelf supports too. So I've got that. I'm going to hit close. I don't need that anymore. I want this to be just a little longer because I'm going to have a support down here. So I'm going to want to open this up a little bit. It's not important how far. And now I've got my 0.25 inches along the bottom here. So the next step is to get some of these put in place. So we'll take a shelf support or a slot. We'll take a slot now, and I'm going to make a copy of it. Control C and Control V, that gives me a copy. I'll hit the 9 key, which allows it to rotate. You could have also used the rotational tool over here and rotated it. I just simply used the 9 key shortcut and rotated it 2 times. So now I have this extra slot created. I'll take that slot now. Let me blow this up a little bit so we can see it. I'll use the alignment tool like we've been doing before, and I'll use a different version this time. So I'm going to pick this first, then I'm going to hit the Shift key and pick this slot, and I'm going to go ahead and align this to the outside. So that now has me aligned to the outside of this slot. I'll hit close. We also said that we want the slots, I'm moving this down, we said we want the slots to align across this line. I'll use the alignment tool. I'll select this component or this slot, this vector last by hitting the Shift key. So I selected this vector, and then I hold the Shift key, I select this vector, and I'm going to align to this inside edge,
because I want the slots all along the inside of this line. And I'll hit right here. So that tells me that that slot is directly aligned on this line. Hit close. At this time, we've created all the slots for these shelves, and we've created one slot for the back support brackets, I'll call them. And the next step is to create the rest of these support brackets and make sure they're aligned so they'll be in the right location relative to the shelves. So the first thing we want to do is take and move, double click on this, and move this slot so it's right aligned with that guideline that we put in place before. The next thing we want to do is to be able to make sure that it's actually aligned with each of the shelves it's going to support. So to do that, we want to use the support bracket that we're actually going to use. So at this time, we'll take a selection of that bracket by clicking on it. Then we'll hold down the control key to make a copy as we move it, and move it up out of the way. So now we have a copy of the dimensions. I'll click on it, I'll hit the Node Edit key, and I only need a small section to use as a guidance. So I'm going to break this vector down, and I'm going to hit the right key, and I'm going to hit Cut Vector. And right below it, I'm going to hit the right key, hit Cut Vector. Then I'm going to delete this section of the vector by hitting the Delete key because it's got the nodes already selected. I'm then going to take this vector, go back to get out of Node Edit mode by hitting N again. I'm going to rotate this vector 90 degrees by hitting the 9 key multiple times. So now I have the direction I want. Okay, now I have the components necessary to get everything aligned the way I want to with these shelves, and that's the best way in my mind to do this is because we're using the actual size of the components we'll cut. So I'm going to get this aligned the way I want it aligned, and the first thing I want to do is align it inside the component. So I pick this one first, this one second, and now I'm aligned right on this component line that I wanted, which works out just fine. Now I pick this component, and I pick this component, and actually this component. I pick this component and this component, and the reason I'm picking this component and not this component is because you can see this component vectors end right here for the dog bones. But where I really want this to align is I want this shelf to be right aligned and support this section right here. So with that being the case, I need to align the vector to this alignment component. All right, now I've got the support bracket aligned along the direction that I want it to relative to these shelves. So the next one I want to do is I want to click on the slot that will be holding that tab, select the center. You'll notice when I do that, this slot is now centered on this tab, which is aligned with the shelf and the alignment bracket. Hit close. So now that I have this slot and this bracket aligned right where I want it, I need to make additional copies and move them across. And the easiest way to keep everything aligned and not get separated is to actually group these two components. But before I do that, I just realized I really want to make a separate layer for these slots. So I'm going to select each of these slots, and I'm going to move them to a new layer that I'm going to call slots. And I'll make those slots green, just because I can. Hit OK, and now I've got all those slots green, and I've noticed that I've got a double here, so I'm going to delete that. The slot layer, I mean. This is the double. slots. And what I'm focused on is actually doing the building slots. So I'm going to select the slots as the active layer as we go through the rest of this process. It'll save me time in the future trying to actually change all the slots. So actually there is 2 more I want to move to that layer. Alright, so all the slots are on that layer. So I'm going to go ahead now and group. Hold down the shift, grab both of those, hit G for group, or I could have hit group over here, and now I have those slots, and I'll go ahead and make the copies I need to as I move along. This can be somewhat tedious, but I want to make sure everything is actually aligned the way it needs to be. So now you can see that I have each of these support brackets aligned so they'll fit within their individual slots. So the tabs on the end will fit within the individual slots, and the top of the bracket will actually support the shelf above it. And that's the concept of making these snap together shelves extra rigid. Now that I've done that, we can go ahead and ungroup these components by selecting them all and hitting ungroup. So now they're all ungrouped, and the next thing I can do is select all those components by reaching across there and hitting the delete key, and we have the slots in the right location. We now have no need for this extra component. I'll hit delete, get rid of this extra component. These 2 holes, I'm going to move to a layer called holes. I'll make those, let's say, red. Hit OK. So now we have the holes on their own layer. We have the slots on their own layer. The next thing we need to do is take the outside profile cuts and put it on its own layer. So let's do that at this time. Move to a new layer. Make it blue. Call it profile. Hit OK. And now each of these are on their own layers. The next thing we need to do is apply the dog bone fillets to each of these tabs. We still have the right radius, dog bone fillet. Now that we have all the components built, the next step is to set up the cut sheet so that we have the correct number of pieces to put a full shelf together and then cut the material. So the easiest way I have found to do that is to make each individual component, like the side shelf and the support brackets, etc., a group so that things can't get moved around. If they have more than one vector, I don't want it to move around, so I'm going to select that side piece and I'm going to hit G for group. I'm going to select this lower vectors and hit G for group. And now these are each grouped so that when I move these components around or these sets of vectors around, they don't end up getting out of alignment between the slots and the profiles, the holes and profiles, etc. So the next step is to set up the actual cut sheets for this. The easiest way to do that is using the VCarve Pro nesting tool. So we'll select nesting. We want to use a 1/8 inch compression bit as we set up the cut pass. Clearance between each of the pieces, that's clearance between each of these pieces, I'm going to leave at 0.5 inches. That will allow me to have enough room for tabs and have secure support. Others might want to be a little more aggressive, and that's okay. The border gap I'm going to leave at 1, and this gives me plenty of hold down space for when I'm cutting these sheets later. I don't need to rotate the parts. I don't need to mirror the parts. I don't need to allow parts inside of other parts. I do not want to remove the original parts because I want to keep these parts together for future use. I don't need to do anything in the sheet options. Active sheet is components. So the first thing I want to do is select the number of copies for each component I need. In this case, for this top component, I need 2 copies of the side shelf. Hit apply. You can see a 2 pops up in the middle. The next components I want to do are the 2 bottoms of the shelf. Hit apply and come down to this component here, and I want 5 of those. Hit apply, and so now what I have is 5 of that bottom. If I hit the shift key and select the middle, you can see the shelf, I should say. You can see there's a 5. I'm holding the shift key and I select the side shelf, and you can see now that we have 5 of the shelves, 5 of the shelf supports, and 2 of the sides. The active sheet is components, which is where we're at. So if I hit preview, what will happen is now the program, the VCarve Pro, will add 2 more sheets, the same size as the original components sheet. And it will nest the components on there in the way it sees best to be most efficient. I like that. I'm gonna hit OK. Someone could rearrange these to get less wastage, but that's not the purpose of this video. And so at this time, I'll accept that and move on to the toolpaths. Toolpaths, we're gonna set up using the layers option. So the first thing we want to do is ungroup each of these into their individual layers. So we're going to select all of the components on component sheet 1. We're going to ungroup objects back onto their original object layers. And as you can see, each of the profiles ungrouped onto the profile layer and the slots on the slot layer. At this time, I'll go ahead and set up a profile cut. Put in Z to ensure it goes down to the bottom. I'm going to use a 1/8 inch compression bit, so that works for me. It's already been pre-selected. I'm going to cut the slots, so let me come in here because I want to cut the slots. Close. And the slots I want to cut on the inside, so we'll cut inside. We don't need any tabs. We've selected them to select all the slots. I'm going to call this slots 1, so I know it's my first cut sheet. Hit calculate, go to 2D view, close. I'm going to select a profile cut again. This time I'm going to select associate with toolpath, slots, profiles, close, and you can see that it's selected all of the profile cuts. 0.235 was what was selected with Z. That'll work. Now I want an outside cut. I'm cutting the outsides of these. I don't need a separate last pass. I'm going to put in tabs, 0.25 by 0.125. I'm going to edit those tabs, and I'm going to use 4 tabs, add tabs, so I have plenty of connection points. Those tabs look good to me. So we got tabs, we got everything else set up. I'm using the compression bit, so I'm not going to ramp it. I'm going to go ahead and put down here Prof 1 so that I know that's my profile cuts on my first sheet. Preview the visible toolpaths, and everything looks good to me there. Go to the 2D view, hit close. And now, cut sheet 2. Once again, I'll do the same thing. I'll select all of those pieces. I'll ungroup them onto the original object layers. Check to ensure they're in their original layers. They are. Hit a profile toolpath, selector. This time I want to select the holes first. Close. I want to go 0.235. I don't need to change that. Inside, no tabs, nothing else is needed. I'm going to change this to holes 2, so I know that that's my second cut sheet. Go back to the 2D view, profile cut, selector, associate with toolpaths, select profiles, hit close, make sure that's what's selected. They are. This is good, this is good. Now I need an outside cut. I need to add tabs. Need to edit those tabs. 4. Add tabs. Close. I'm going to call this Prof 2, so I know it's my second sheet. Hit calculate. Preview the visible toolpaths to make sure everything cuts the way I think it is, and we're ready to cut. So now we set up our toolpaths for both sheets, and it's time to go to the Laguna and cut these sheets.
All right, we just completed the video demonstrating how to design this snap together shelf with snap together joinery, and we're about ready to go ahead and cut the shelf. Let me cover a couple things based on what we did in that design video. In the end, remember, we have 2 sheets of material that we're going to have to cut on to get the full shelf built. So this is sheet number 1, and this is sheet number 2. You'll see me switch sheets halfway through the video. The other thing that I've done to make it easier for hold down is I've put 2 lines on here. So I've marked where the breaks are going to be between the shelves so that I can put some hold downs in the middle. One of the things I found out through experience is if you want to have nice, crisp cuts, there's a couple things that you need to do. Number 1, you need to use a compression bit. Number 2, you need to make sure they're held down, and with a sheet like this, there's flex. While it's cutting, it'll tend to bow up a little bit. So you want to have hold downs in the middle of the wood as well as the ends. So I marked these lines to know where I can put a hold down in. The other thing is we don't want to take a risk on damaging our bit. So we're going to use a special tool today when we hold this down. I have this Omer bit, this Omer nailer, and in it we use nylon nails. What that means is if I'm off in my hold down, the bit hits this, it will not damage the bit. Those nails I will only use in the middle because I've already been able to mark out on the edges and I know where those go. So I can use regular screws for those. So now we've talked through the setup of how we're going to hold down. I'm going to use nails, not nails, I'm going to use screws on the side. I'm going to use the nylon nails on the end. I could use those here. And the next thing I'm going to do is I'm going to put in my bit. I'm going to zero it on the edge. One of the things you will notice is that I'm using an 8-inch compression bit. I talked about that in the design video. I did that because that was the only compression bit I had available for using to cut at that time. It also allows me to put more material on one sheet. If you have a 1/4-inch compression bit, you can go ahead and use that and your cutting speeds can be a lot faster. For this demonstration, we'll be using my 1/8-inch compression bit. So at this time, I'm going to go in, set up the material, and put in my bit. One thing, before I set up the material, I want to put my bit in and zero it because I'm zeroing off the bed to make sure I get all the way through on these cuts. Now that I've zeroed the bit, I'm going to move it out of the way. Sheet 1 of 2, I'm going to locate it right here in the corner. Hold it down. What I'm doing here is making sure that I'm not going to hit the aluminum track that it's actually holding. So now I've got everything held down. One thing you might be asking is, well, if you know that you can't damage a bit with these nylon nails, why didn't you use these for all the hold down? So the reason I don't use the nails for all the hold down is sometimes they can be a little bit of a bugaboo to get out. Because what's going to happen is when I try to take this off, you'll probably see it, I'll end up snapping these nylon nails. And then I'll have to go ahead and just kind of shave off the head so it doesn't interfere with my spoiler board in the future. It'll be fine. They'll be left in the spoiler board, but sometimes they're a little tough getting off. So if I don't have to use the nylon nails, if I have a good location and I'm not going to damage the bit, I know I'm clear, I won't use the nylon nails. So with that, let's go ahead and zero this machine in the XY direction. We've already zeroed it in the Z, recall. Before I put the material down, I zeroed it off the bed. Now this is not a critical evolution. We just got to get close to this corner. Because we do CNC, we tend to get a little, want to be accurate, so we're going to make sure that we get it as close as possible. Lining up with the 0 bit. Okay, we're in the right location. I'm going to hit X, Y, 0. I've already zeroed out the Z. So now we're at the point where we can go ahead and run our toolpath. We have our X, Y, 0, our Z, 0. We're now ready to cut the material. What you'll see is a series of cuts. It'll be 2 passes and then we'll be done. So we'll go through sheet 1, hit OK, and after we hit OK, then we'll turn on the dust collection. Sheet number 1 is done now, so now we're going to switch to sheet number 2. We'll take sheet number 1 off. Okay, as you can see, the nails are stuck there. So what we have to do is use a little gentle persuasion. This is what I was talking about with those nails. So that's what it looks like. You can see it's nice and clean on the top. Pull it down for a second. Let's take a look at what the bottom looks like. So that's why we use a compression bit. If we weren't using a compression bit, there would be a lot more tear out. There's hardly any tear out on the bottom of those cuts. So now we have a nice clean cut on the top and the bottom by using that compression bit. Now you may recall me mentioning before, I don't always use the nylon nails for all the hold downs because they have a tendency to snap and break off. And here's an example of one right here. I don't know how well you can see that on the video, but this is sticking out, and that will throw your material off if you allowed that to stay. So we'll have to clear that off. And so all I do is simply break it level with the top of the spoiler board, and then it's not a problem. But you want to be paying attention to that. So what I'm looking for here is, here's the line I was using the nails with, right here. And that was the only one I saw there. And the line over here looks like I'm okay. So now I look like I'm fine. That's the one reason I don't use nylon nails on everything. So let me clear out the spoiler board and lay the next sheet down. The bit is already zeroed, so that's good. I zeroed off this corner to begin with, so it'll be good if I just line this up with this corner right here. I know that I'm safe at 15.5 inches and up. One thing I didn't share with you before, and I didn't print this out on a piece of paper so it's not as easy to see, but before I came out here, I actually printed out a map of where the hold down locations could be so that I knew where the best place to screw was. So in this case, I knew that as long as I put a screw anywhere between 1 and 1.17 on the left side, it wouldn't have a problem with the bit. Actually, anywhere between 0.75 and the edge. Over here, anywhere between 4 inches and the edge on the right side, and here, anywhere 15.5 inches and out. So I put this map together. I did the same thing for sheet 1. I didn't demonstrate that before, but thought that might be of interest to you. Create a map sheet for you to know where to put your hold downs. So now that we have the board fastened, everything's held down, nice and secure, we can go ahead and cut the second sheet. I'll check the zero real quickly on the XY just to make sure. Yes, that looks good. So here we go. We're going to start with sheet 2, 1/8 bit compression. We just finished cutting this project. Now it's time to remove it from the bed. Once again, that's the advantage of using a compression bit. If I had just used a down cut bit, the top would have been clean, but the bottom, we would have experienced a lot of tear out and a lot of repair, sanding, etc. That's not the case either on this sheet or the other sheet. If I had used an upcut bit, then the bottom would have been good, but the top would have been experiencing tear out. So that's why you use a compression bit. In this case, I used a 1/8 inch, a 1/4 inch, just a compression bit is all that matters. Okay, the next step is to cut all the tabs in those slots, pull each of those slot pieces apart, and start putting the shelf together. When we get done putting the shelf together, this is what it's going to look like. As you can see, the design is pretty sturdy. It's held with all of these snap together tabs that go into these slots, and we've designed it so that the shelf support brackets go right underneath the back. So not only does it hold it against the wall, it stops the shelf from wanting to sag. That was an intentional design characteristic of this shelf. Very easy to put together, very easy to break down if you decide you need to break it down. One of the key things to this shelf is actually this slot size and this tab size. You got to get those right. So one way to do that is to build yourself a storyboard. That can be seen in another video if you're interested in looking at it at Generations Custom Creations YouTube channel. Thank you again for watching. Really pleased with how this piece turned out. The joints are tight, the shelves are strong. If you liked what you saw, please like, share, and subscribe. You can also put comments below on any future ideas or videos you would like to see come from us. Thank you again. Hope you have a nice day.